Welcome back. We can see that our objectives for this video are to describe and define the different types of energy, and then we'll do some conversions between different energy and temperature units. Let's start with a little introduction. Energy is going to be everything in the universe that does not qualify as matter. As we recall, matter is everything in the universe that has volume and mass. Energy is going to be the opposite. Instead of having volume and mass, energy has the capacity to do work. That is, work in the physical sense, in physics, where we're applying a force across some distance. We know that mass has to be conserved during our chemical and physical processes. Well, the same is true for energy. Energy will also never be created or destroyed during our processes. Energy can be changed from one form into another, and it can also be transferred from one substance to another substance, but the total energy of the entire universe must remain constant. Let's talk about those forms of energy. The general forms of energy are either kinetic or potential. Kinetic energy is energy associated with motion. This could be objects moving side to side. This could also be objects spinning around. This could also be objects vibrating back and forth. Lots of different types of kinetic energy are possible. The other major category for energy is potential energy. Potential energy is energy that is stored within a substance based on its position or perhaps based on its composition. We said that energy must be conserved, but it can be converted from one type to another type. Here in this top picture, we have a waterfall where the water is going up over the edge of the waterfall and falling down. The act of water falling down is a lot of kinetic energy. That kinetic energy can't just come from nowhere. It has to be coming from potential energy, energy stored within our water up at the top of the river, based on its position, based on gravity. That potential energy is then released and converted into kinetic energy as our water falls over the edge. The same principle applies to our dams. Here we have our water above the dam has a lot of potential energy based on its position. As it falls through the dam, that potential energy is converted into kinetic energy. And our job in the dam is to convert that kinetic energy into electrical energy, which we can use elsewhere, power our devices, power our grid. We can focus in on a couple of specific types of energy in our chemistry course. One type is thermal energy. This is a type of kinetic energy, random motion of our atoms and molecules based on our temperature. We can also think about chemical energy. This is a type of potential energy where we are storing energy inside of chemical bonds. Energy can be quantified, and if we're going to quantify and measure or calculate the amount of energy in something, we need to have some units. The SI unit for energy is the joule, but this is not always the most convenient unit. We might have seen calories, or maybe this capital calorie, in our lives when we're eating our snacks. This capital C calorie is related to our lowercase c calorie, which is related to our joule unit. But these are all units of energy. Our last unit down here is the kilowatt hour. This is what you might see on your electricity bill, another unit of energy that shows up in our lives. We have a practice question here. Can we convert from calories with a lowercase c into units of kilojoules? It seems like this should be possible in just one step if we have our conversion table listed out here. Let's start with the value that we know. Then we can try to set up our fraction. Let's cancel out the value that we don't want to have. Let's make sure that we have the value that we do want. Oh, and just kidding, this is not kilojoules, this is regular joules. So we can take a stop in regular joules and then convert over to kilojoules, a second step. Our conversion here, 1 calorie is the same thing as 4.184 joules. So there we go. Our first step is all set up. Our second step can go from joules to kilojoules. We want to cancel joules. Let's put that in the bottom of our fraction. We want to end up in kilojoules. Let's put that in the top of our fraction. I like to ask myself which is bigger. Here a kilojoule is big. We're going to need 1,000 of those little joules to be the same as 1 of our big kilojoules. We can plug this into the calculator and get our final answer. We said that energy can only be transferred. It must be conserved in the universe. So we have 2 types of processes. We have exothermic processes. These are going to be processes that release energy, that release heat towards the surrounding as they occur. Things like burning reactions release heat to the surroundings. Those have to be exothermic. We can think of exothermic with the same kind of language roots as the word exit. The alternative is when we have processes that need to absorb heat in order to occur. This is going to be called endothermic. Our example here is one of these instant ice packs where you smash the little plastic bags that are inside to have some process occur. That process absorbs heat from its surroundings. Maybe that's your twisted ankle or sprained wrist or whatever. If you like a way to remember this, we can think of endothermic like entering. We need to have heat absorbed to do that process. We've mentioned thermal energy already, but let's define temperature as something that is different in chemistry than heat. Temperature is going to be a measurement of how much thermal energy something has, but it is based on random motion of our particles and must have different units and different values than pure energy units. Heat, on the other hand, is exactly a measurement of energy. It is a numerical energy value and needs to have units of energy. This is a subtle thing, but we need to be careful with our terminology. If we're thinking about units of temperature, we have 3 common units. In our lives, we've probably mostly used Fahrenheit. This Fahrenheit scale is based on, well, historically based on body temperature and the temperature of ice water brine. So our 100 mark is around the temperature of a person, and our 0 mark is around the temperature of salt water and ice. It's a weird scale, but we're probably pretty used to it in our lives. In science, we're not going to use this scale as much. Instead, we're going to focus on the Celsius scale and the Kelvin scale. In the Celsius scale, everything is based on water. The 0 point for Celsius is based on water freezing. The 100 point for Celsius is based on water evaporating. This is pretty useful, and we do like to use the Celsius scale a lot. But actually, even better in a lot of calculations is going to be the Kelvin scale. The Kelvin scale is exactly the same as our Celsius scale, except everything has been shifted down by 100 units. We do this so that the 0 point in our Kelvin scale is now absolute zero. It is the lowest theoretical temperature that anything could exist at in the universe. Nothing will ever get below this absolute zero temperature because this is exactly zero energy. You can't have less than zero for your energy. This is going to be our best temperature scale because it makes a lot of calculations possible and very easy. To convert between our temperatures, we have two different formulas. This top formula is a good one to memorize, converting between our Celsius scale and our Kelvin scale. All we have to do is add or subtract 273 to switch between those two scales. Our second equation is for switching between Celsius and Fahrenheit. Honestly, this might be more useful in your everyday life if you're talking with people from other countries. But it won't be a major focus for us. We'll usually measure things in Celsius and do our calculations in either Celsius or Kelvin. To use this second equation, you need to do a subtraction and a division step, because not only do our Celsius and Fahrenheit scales have very different 0 points, they also have different size degrees. 1 degree Celsius is much bigger than 1 degree Fahrenheit. Meanwhile, 1 Celsius changing by 1 Celsius is the same as changing by 1 Kelvin. We have a couple of practice questions on this slide. Feel free to pause, try to write down some good answers, and see if you can get it. There we go. We have introduced our different types of energy, and we've introduced energy and temperature units and can convert between energy units, convert between temperature units. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.